Okay, so OVComposer. Once you install the basic empty fact store, the next thing we're going to do is we're going to create our own. So we create our own fact stores or correlators by using the OVComposer space minus UI command. Now, what's important here, folks, is that this command, you can only run it in an X-enabled display. It won't work if you try it through PuTTY for any of its options. So everything you do with this, you'll have to do it through the VNC window. OVComposer space minus UI. Okay, so from here, then we can create our own fact store file. Now you can spread your correlators across multiple fact store files, but when you deploy it, they all wind up in one fact store file called ecs_comp.fs. So it's probably best practice to put all your correlators into one file, and then it's easier to manage and maintain them. So you go to File, New. You're going to specify the types of events you want to correlate. So the two that we work with are SNMP for traps, for network type correlations. The one that we obviously want to go for here is OVO, and it works with two other types of messages. These get used in a lot of telco systems, X733 and CMIB. Okay, so once you create your empty fact store file, then the next thing you do is you decide what types of correlators you want to put into it. So the different ones we have are enhance, multi-source, rate, repeated, suppress, and transient. So as we enhance allows us to programmatically change an event. So as messages come in, we can make modifications to them. Multi-source, this is quite a powerful one for OM. This is where we can do advanced root cause analysis type stuff. So we can relate different types of messages together and either suppress all of them and create a brand new message from it, or allow some of them to come through and suppress others. So for example, if you have a web application that's relying on a back-end database, then we could set up a multi-source to say that if the web application message comes in, we're only to allow that into the browser if we haven't received the Oracle database message. If we get the Oracle database message, then we know that's the root cause of the web problem, so that's the one that we would allow through. Rates are where we can get it to generate a new message if a certain type of event happens so many times in a time frame. Repeated is where we can get it to tell us at the end of a time frame how many of a certain type of event has occurred. Suppress is where we can do advanced type filtering, and that's the first one we're going to kick off with this morning. And transient, as I said, we use that for network type correlators. So this is where we can check for things like flapping interfaces. We expect interfaces to go up or down, but if they do it at a certain frequency, then that means that we've got a major problem. And then user defined is basically where we can create our own special correlator, either using something like Perl or C, that will basically get a feed of messages from the MSI, and then it can decide whether to feed them back in again or not. The one we're going to start off with this morning is a suppress. So when you create a correlator, you give it a name. So I'm going to call this my suppress correlator. Then in the description you give it an overview of what it does. So I'm just going to say here, this will suppress messages. Field. Best. In the definition part, this is where you do most of your configuring. So with Composer correlators, there's three basic parts. You've got the alarm signature, you've got the variables, and you've got the advanced filter section. The alarm signature decides whether this message is going to be accepted by the correlator. So for example, if I specify here that the application field equals test, then what happens is messages come into the correlation engine. OM will test those messages against all the correlators at ARM signatures. If it doesn't match any of them, then it's allowed to come back into OM. If it does match one of them, then the correlator will decide whether to suppress the message or not. So in this case of a suppress correlator, any messages that contain the field application set to test will be matched with this correlator and will in effect be suppressed. So that's the first exercise we're going to go through, something just very simple to test it. The second thing that we're then going to go on and do is start using the variable section. So messages come in, they match the alarm signature. It then comes down to the variable section. This is where any variables you define will get evaluated. And then in the advanced filter part, we can then do tests on that. And we're going to do that in our second exercise. We're going to have a message come in. We're going to create a variable that makes it call out to an external Perl function. And depending on the value that comes back in, we will either suppress the message or not, based on the advanced filter part. So, once you've got them set up, then the next thing you need to do is you need to do File and Save. So I'm just going to put that in. I'm going to call it teststore.fs. And it's important to close the correlator when you've saved it before you try and deploy it. And then the next thing I do is I'm then going to try and install that. So /root. Okay, so the format for the command to install it is OVComposer space -install space -ms space -fs. And then what you need to specify here is all of the fact stores that you want to deploy, because this will override any ones that are already there. This is what I'm saying to you, it's probably best practice to put all your correlators into one fact store file. And then the fact store file that I just set up there was teststore.fs. Now, because this OVComposer is a GUI command, it will only run in an X-enabled display. If you try and run that command from PuTTY, it will fail. So everything you do has to be done through the VNC window.